So this video cover the concept of dynamics and how it's different from statics, and also the differences between kinematics and kinetics in dynamics. So intro to dynamics. So when it dynamics, we have dynamics. We have the Newton's second law equation. Sum of all the force equal to ma. And in dynamics, we study both the forces and motion. So when it has motion, the A is non-zero. And that's different from statics. As you recall, in statics, we have, I just write down here, statics, if you recall, we only study the forces, not the motion. So the body in static equilibrium, and we have sum of all the force equal to 0, because in that case A equals 0. So that's the difference between statics and dynamic there. Now let's talk about the dynamics. In dynamics, we have two major topics to be covered in this class. The first one is kinematics. And then the other one is kinetics. So what the difference between these two? In kinematics, we study the geometry of the motion, not the forces. And in kinetics, we study forces that cause motion. Forces that cause motion. So that's the difference between kinematics and kinetics. And in kinematics, we have two major topics to cover. The first one is particle kinematics. And of course, the other, it will be rigid body kinematics. So that is one branch of dynamics to kinematics, and in kinematics we have particle kinematics and rigid body kinematics. And as you can see, similar to equilibrium, we have particle equilibrium and rigid body equilibrium in statics. And talk about kinetics, which is study forces that cause motion. How to conduct that study? So basically, we have three methods that will be introduced in this class. The first one is the force acceleration. So we want to know the relationship between force and acceleration, and basically we study the direct application of Newton's second law, which is F equal to ma in there. And then the second method that we are going to cover in kinetics, which is work energy. So relationship between work and energy. And then the last one, it will be impulse momentum. Impulse momentum. Okay, so that give you the overview of what we are going to cover in the dynamics for the remaining of this semester. So let's talk about kinematics for today and next lesson. So kinematics. So as you can see, kinematic, we study the geometry of motion, or in other words, we study of how object move, how an object or multiple objects, right? You can say, okay, let how objects move. So not about the force, not why. And in here you can see in kinematics we have particle, kinematic, and rigid body. So let's talk about what the difference between the two. So let me start with the particle kinematic. So when in particle kinematics, we only need the location of the particle or that object can describe the motion. So we can have for particle kinematics, we have the location of an object fully described motion. And then the difference with the other kinematics, which is rigid body. And in that one, not only the location, but it also we need to know the orientation of the object. So it have to be both location and orientation. So direction of body or object require to describe motion. Okay, so far as you can see, we go over the dynamics and how that different from statics, and also the two major topics we are going to deal with in dynamics with the kinematics and kinetics. And in kinematics we have particle kinematics, rigid body kinematics, and we also know what other method we are going to use in kinematics, which is the three: force, acceleration, work energy, and impulse momentum. And because kinematics, we study the geometry of the motion or study of how objects move, not why. So I want to emphasize here, not why. That will be in kinetics, and we have particle kinematics, only the location of object. For the rigid body kinematics, we need location and orientation of objects to describe the motion. So with that, we move on to the next video for more about the